Hey guys, what's up? This is Alex Duque, and my mic is not putting correctly, so give me 1 second. Okay, hey guys, what's up? This is Alex Duque, and welcome back to another excitingly simple tutorial. Today we are talking about dynamic constraints. Those guys are pretty cool because you can do a lot of cool things with them. Last week we already talked about actives and passives and fields and all that stuff and how they behave and how you can, connect them and all that stuff. But there are extra things that you can do that are really cool with um, these constraints: nail, pin, hinge, spring, and barrier. For example, if I make myself a little sphere here and then I make it active. You remember that with gravity, and you remember the step 2 thing, that if you just go fields, gravity is going to make it an active body and link it to the gravity. Well, if you select it and you make let's say any type of constraint, is going to make it active and link it to each constraint. So we can just select our sphere there and say fields, soft rigid bodies, nail constraint. Now if we press play, then nothing is going to happen. By the way, something I forgot to mention last week, and I might mention it this week, it's an essential to dynamics, is that when you work with dynamics, make sure you go into your animation settings and you make sure that the playback speed is play every frame. By doing that, then dynamics will compute correctly. Otherwise, they're going to behave weird. So make sure it's play every frame. And then you gotta be careful. You gotta make sure you play blast your motions to make sure that things are correct. So anyway, so I'm gonna select my sphere here and give it a gravity. And if you press play, you'll see what's gonna happen there. Yay! It's doing its pendulum thing. That's exciting, isn't it? There's one main thing wrong here, though. That is that um, our pendulum, our sphere, doesn't have any. It's not losing energy as time progresses. Theoretically, each time the pendulum strength should be less and less and less. So we would have to increase that. And one way we can do that is by increasing the damping. So we go ahead and change the damping to, let's say, 0.1. Now damping, depending on the amount of strength that's being exerted onto a particular object, that damping value would be very low or very high. You can see I give it a 0.1 and there's a lot of damping going on. So now the motion is a little bit more real. But again, always make sure you play blast your scenes. I'm just going to go up to 300 here. I'm going to make a play blast just to make sure that the motion is correct. It's not like going too slow. So I'm going to just go ahead and click play blast there. And let's see what happens. So you can see that its actual motion, although it looks like it's fast in Maya, now that you're seeing it here, you can see that it's like as if it was in space. Doesn't have realistic motion. So if that happens, you would have to select your magnitude and increase it. Now, if you remember me talking about the real world dynamics last week, then this gravity has a magnitude of 9.8 meters per second. And this sphere right now would be a 1 meter sphere, actually a 2 meter sphere. So that'll be like a 6 feet diameter. That's a huge sphere. Let me just make sure. Let's see what it says. It's got a radius of 1, yeah, so it's got 1 meter up, 1 meter down. So this is a 6 feet, just about 6 feet. That's a huge sphere, and that's why the motion looks slow. because it would be a huge object. So what we can do here is just increase our magnitude to maintain the scale. You know, if we think of this sphere as a pebble, for example, then it would be 1 centimeter radius, for example. So if it's got a 1 centimeter radius, then that means the magnitude would have to be in centimeters. So it would be 980. And if we go ahead and make a play blast again, then we are able to see that motion there. And because there's more mass, more gravity than my original damping, you know, it's not as intense as it used to be. But now it behaves more like, for example, I don't know if you've seen those Newton balls. That is just about the right speed for those little spheres. They would go pretty fast. It would have a lot of motion to it. So just keep that in mind to keep things in the right dimensions, real time or real life. Okay, so since we're working with 980, yes, yeah, that's a 1 centimeter. Yeah, that's about right. Then we can keep going and we can play a little bit more. Now, as far as the constraints go, we're going to talk about all of them. This is the nail constraint. Now, the nail constraint doesn't have much, is not, you know, nothing fancy to it, except that and this is a value that all of them have, which is that constraint value. If it's on, there it means that there is a constraint. If it's off, then that means that there is no constraint, so our sphere is just going to fall. Now, you can again do cool effects there. I can, for example, keep that off until there, and 1 frame later, key it on. So this is what is going to happen. See what's going on there? Or vice versa. I'm going to open up the graph editor, select the pin constraint, open up the graph editor. There's the constraint thing. And I'm just going to do the opposite. It's going to go from on to off. So, whoop. Okay, that's a little bit too quick, right? So you can see, oh, oh, beep. So, as you can see, you can key that. Now this, like I said, it's a simple type of constraint. I'm going to break the connections of that animation there. And one of the main things about this type of constraint is that it doesn't have any axis. If let's say, for example, this sphere had an initial velocity on the x of, let's say, 10 units, then, okay, let's say 100 units. Oh, did I say? My bad. X is going to be pushed this way. Okay, let's give it 100, make it more noticeable. See how this doesn't have a constraint, or it doesn't have an axis. It can go, you know, wherever it is that it's going. That's the it's like a hinge that can rotate anywhere. Okay, so now let's just select it and delete it, so there's no more constraints there. And let's go ahead and talk about the next one. Why don't we, yeah, well, let's just delete it and say soft rigids, and let's do a hinge constraint. Well, actually, you know what? To do any of the other guys, well, let's do the hinge. Yeah, we can do the hinge here, since we can hinge it to itself. So it will be a hinge right there. And as you can see, you see the axis of the hinge. So that's the axis that this is going to be rotated on. So now it's going to do that. But of course, you can rotate the hinge. So it's actually going to work that way. It's all based on that rotation. If I do it like that, then it's kind of like going to do like that. So 0, 0, and 0, and translate x 0, translate y. I'm gonna make it 10, and I'm just gonna move it on the C front and rotate it on the Y 90 degrees. So now it's like a swing, and it's sort of like exactly like the pin looking like right now, except that, like I said, this one, remember that initial velocity that we had set on our sphere? See how it's not reacting to that initial velocity? It's just gonna go front and back, period. Might move a little bit to in the X direction, but aside from that, it's not going to like rotate around. Alright, so that's the hinge. Like I said, nothing fancy. Why don't we go ahead and make another sphere? And let's just move that sphere a little bit to the side. And why don't we get crazy and make another sphere and move it up somewhere, wherever the hell you want. And we can do something a little bit more exciting here. Why don't we select that top guy and give it a nail constraint. Just move it on top. Make sure you link it to gravity though. Window, you remember how to link it to gravity? You would select your sphere. You don't have to select it, but you can go Window, Relationship Editors, Dynamic Relationships, and just link it to the gravity. Might as well do the same thing for the other guy. So if we press play, they should all, except that guy, because it's got the pin constraint, they should all fall. Oop, exactly. Now let's move this guy a little bit over to the side so it swings. There we go. Now here's when things begin to get cool. If we select that sphere and that sphere, we can go ahead and talk about the pin constraint. The pin constraint is going to make a constraint between two dynamic objects, and the axis of rotation for that pin is going to be right where that little square is, so I can actually move that square wherever I want to. So if I press play, you'll see what's going on there. And that can be again placed anywhere I want, so I can actually put it up here, so that would be what's happening there. Okay, I'm gonna make myself another sphere, and I'm also going to link it to the gravity. Dynamic relationships, and link that guy to the gravity, and press play, and he's gonna fall. And I'm gonna give this guy a nail constraint, and I can actually parent this nail constraint to another object. Isn't that fancy? So we're beginning to get more exciting results. Now, we got the pin, we got the nail, and the hinge. Remember that we made a hinge to the object to itself? You can actually hinge between two objects. So if you select a sphere and another sphere, and you go ahead and make a hinge, now it's going to make a hinge between those two objects. Just need to rotate that 90 degrees there. And if we press play, then that's what they're doing. But you can actually make one of your spheres passive, and I'm just going as I'm going, just to explain these values without any final result in mind. And now this guy and that guy are trying to do something, but this guy is really not allowing them to do anything. If we do that, nope. Let's see, what if we do that? Nope. If we do that, okay, there we go. We're getting a little bit of a different result there. Okay, why don't we make this guy passive and this guy active? Yay! Okay, so now we're getting a bit more of an exciting result there. So you can see how this is all like starts working together. And then there's another guy, which is the spring constraint. Spring constraint kind of works, think of it like a rubber. So if you need to link an object to another, kind of like a rubbery like connection, then you can go ahead and use the spring constraint. So let me select this guy and that guy, and effect create rigid, create spring. Now, right now, there's not the spring constraint. I haven't talked about the values for all of them because they don't have a lot of values to talk about. The nail constraint has the constraint that you can key. The pin constraint has this interpenetrate option. So if that is set to on, that means that it will it allows to interpenetrate itself. Right now, like this line can't collide with that. If that's set to on, then it's allowable, so they can penetrate with each other. But, it's not like there's a lot going on there. This is the hinge, which has the same values, and then we go to the spring. The spring has more values here. You got stiffness, damping, rest length, interpenetrate, and constraint. Interpenetrate is what I already talked about, so it can penetrate with itself. The rest length is sort of like a time for it in frames for it to like relax itself. The stiffness is what make it more or less stiff. So if that, let's see if this should be a passive, an active body. I'm just gonna link it to the gravity here, so we can see it working. You can see how that's like rubbery and stretchy. If that stiffness is higher, then it's going to be a little bit more solid. And that guy comes and plays a part with damping. The damping would be so that if it's stiff, it doesn't start bouncing around, and that we'll see in a little second once I do another example that actually has purpose. And then the constraint, like all of them, can be keyed on or off. So like for example, if let me just press play here, and I'm going to key it off there, and I'm going to go one frame before, and I'm going to key it on. So it's going to, and then that's it, no more behavior. It's going to do its thing and fall off. Fall. Alright. Now this is pretty much all the types of constraints. There's one more, the barrier. If I select this guy and I say effects, create barrier, the barrier is a barrier, so it's pretty self-explanatory. You can scale the barrier, and it's just gonna make a barrier, so that would make the constraint collide there. See? It's not going anywhere because it's a barrier. It can't go past it. And if I put it, underneath, then once it reaches that, it's gonna get to that barrier. And if I put it like that, then once it reaches that area, it's gonna hit that barrier. See? So on and so forth. It's sort of like a passive body, but a little different. Alright. Now, what's all this for? I know this is a very weird example, just showing you how things work. Let me save scene as, I'm going to save this as week 2 constraints. But make a new scene. Yeah, what am I saying? But you can actually use the constraints for something constructive. Let me suppose I have these little cubes here. Usually when you do dynamics, you have low polygon stand-ins. Let me redo this. You have stand-ins, and those stand-ins will eventually drive. They would behave correctly, and that would drive high poly meshes. The thing with dynamics is you don't want to be like too crazy as far as the amount of information. The simpler they are, usually the better their behavior, so you want to keep it as low poly as possible. So for example, I can select these two guys. Actually, I can select all of them and say fields gravity. Now they're gonna fall down. Right now these are a meter by a meter, so they get really big. Why don't we go ahead and increase the magnitude? I'm gonna do it 98, so it's not too crazy, but not too light. There we go. And go ahead and make a floor there. Now this is something that's interesting when you do dynamics. This is my floor plane right now. If I display the normals, that is where my normal is heading. Okay, so that means I'm going to rotate it like this, which means that the normal is going to face down. Okay, now I'm going to make this a passive body. Theoretically, if this is a passive body, it's going to collide with those guys, remember? But if I press play, and increase this, make sure that I'm playing real time. I'm sorry, every frame. So press play, and theoretically it should collide with the floor, correct? Well, no it doesn't. And the reason why it doesn't is because the collisions for dynamics are based on the normals. So again, my normal is facing down, so if I wanted this to work correctly, I would have to either reverse my normals, which is one option. So now the normals are heading in the right direction and then the collisions are working. Or back to how it used to be when we reverse those normals. Or you can extrude the object and give it some thickness, and by giving it some thickness, then that is ensuring that the normals are all heading out. So you got both options. It's up to you to which one you want to choose. And just check my face normals here. They're opposite. Yeah. So now that they're correct, then there you go. So you can see what's happening there. These guys are colliding with that. Now, back to the constraint. So if I select this guy, shift select that guy, and I say, so now we're going to actually do an effect. Just make, you can do two things here, but I'm going to start by doing a pin constraint. And then do another pin constraint between those two, and another one, and another one. Remember, if you press G, it's going to do it again. And another one, and another pin constraint. Then I select all my constraints, and I don't keep them in the middle, but I just move them all to the side. There we go. Now it's not going to look like much because they're all going to fall, but they're all going to be linked, kind of like a cable, see? And if I actually go ahead and select this and that guy, and I don't know, I tell them passive, then those guys are going to stay there, and these guys are going to fall. Well, that's stretching, but it's working. Now, another thing I can do, instead of making these guys pin constraints, is making them, I can actually switch them. If I select them all, I can change the constraint time from pin to spring. And now of course we're going to press play and they're just going to like stretch out. Let's give it a lot of stiffness. Let's say, I don't know, let's try 100. So now it's a little bit more rubbery. Why don't we say 500? It's a little bit more solid now. Let's see how it's just like do 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 toin 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 toin. Or we can give it damping and try to fall like gentle down. Let's see. I was still doing it. So why don't we give these guys damping, or give them dynamic friction? And let's just go with damping though, since they should have damping anyway. Damping. There we go. So see how they're like getting more gentle until they stop. Now what's cool here is let's select this guy and let's hit frame 380. Now middle mouse clicking. I want to select this spring, or let's try this. Select this guy and I'm going to try active, key selected. I'm going to do one frame forward and active on. Now I'm just going to make sure that this guy is linked to gravity. So it's passive and then it becomes active. So they're gentling out and they're playing and we're playing frame 200, and then we're going to get to frame 380 and see what happens there. Whoop! See how that stretched and contracted a little bit? That is because of the stiffness of these guys. So although it might work, if you don't do it correctly, then you might end up not getting the correct results, unless this was rubber, in which case then that would probably be what we wanted to get there. Now I'm going to open up the graph editor and I'm going to change that active state. I'm just going to move it up to frame 120 so that this happens faster and we don't have to wait too much. It does its contraction there. You can see how they're trying to constrain to each other. So what's the whole point about this? Well, check this out. If we were to have, I'm going to start by adding all these guys to a layer, making that layer R, and then I'm going to go ahead and make a curve. I'll just make a surface, why not? No, I'm going to make a curve. I'm just going to snap it there, 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 and there. Just going to select all the CVs of this curve, make them straight, there we go. And I'm just going to make sure that there's one CV on each one of these guys, which is what's happening right now. Now at the same time, I'm going to make a cluster for each one of those guys. So if you go to animation, create deformers, cluster, make another one, 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 make another one. And then you parent each cluster to each dynamic fella, because you can't make clusters dynamic, so that's why we made those guys dynamic. So I'm just parenting each cluster to its respective dynamic cube. So if I press play, you can see that our little dynamic curve, I'm going to hide those guys, our little curve, it looks kind of like a rubber band. I don't know if you can see it, but I'm going to play it again so that you can see it. It's doing its thing, it's doing its thing, it's doing its thing, and then whoop. See what I mean? So now we got a natural motion on something that's not dynamic, but it is driven by the dynamics. And then we can extend ourselves a little bit further along and make, well, I want to make a polyplane. I'm sorry, polycylinder. Just just gonna rotate it 90 degrees there. Scale it in a little bit and stretch it out. So 22, 0.2, and 24. I just like closed numbers, rounded off numbers. And I'm going to give it less divisions on the axis. Or no, actually I'm going to get retarded here in the quality. I know it's going to be more than what it needs, but it's just to explain. So let's give it 30 divisions there. 50 divisions. Why don't we make 100 divisions? We got a really high polyplane there. Okay, 5. Okay, so I'm gonna make 10 and 600 just to get insane. I'm only doing this because I want to get insane there. Now I can select that curve, or I can say create deformers wire tool. So I select my curve, press enter, and my object. What? Okay, one more time. Create deformers wire tool. Sorry, select my shape, enter, select my curve, enter. And wire deformer, I might have to change the drop-off distance of this wire deformer. I'm gonna press play and see what happens. Oh, cool! It's being deformed. Yeah, I'm gonna increase that drop-off distance more. There we go. Okay. So as you can see, I got a retardedly high mesh, but that guy is anything but dynamic. It's just that all its motion is being driven by something that is, which is those little guys. Okay, so if you get creative, you can begin to implement a whole bunch of these simple basic tutorials to make something that is actually not simple and retarded. Alright guys, so until next time, I'll be seeing you, and make sure make sure you wear a rubber. Or make one, it's up to you guys. Bye bye.